Good morning. Today I'll see about measurement systems. So measurements, what is meant by measurements? The process by which one can convert physical parameter to numbers, or the process in which the property of an object or system is compared to an accepted standard unit. For example, we are saying a particular fluid is hot. We can specify it in terms of numbers. So it will be mentioned as the fluid is having a temperature of 80 degrees Celsius. So what is meant by numerical measures? The number of times the unit standard fits into the quantity. That is, it is meaningless unless it is followed by units. Hence, it identifies the characteristics or property. So everything should be have under comes under units. So we have for this two requirements. The standard used for comparison purpose must be accurately defined, commonly accepted. Second one is the apparatus used and the method adopted must be provable. That should be provable. Then comes to significance of measurements. There are two major functions. One is design and another one is operation and maintenance. Both must be comes under economical design, operation and maintenance required of a feedback of information. So whenever the science and technology move ahead, it's growing and growing. A new phenomena or relationship are discovered, and these advancements makes a new type of measurements to be imperative. So every science and technologies to be improved, that new phenomena has to be enhanced in every kind of measurement systems. Then move on to the methods of measurements. There are two types of methods, direct methods and indirect method. So direct method, what is meant by direct method? The unknown quantity is directly compared against a standard quantity. The result is expressed as numerical number or a unit. This is not commonly used, and it's quite common for measurement of physical quantities like length, mass and time. So for example, vernier caliper, micrometers, digital meters, etc. Then indirect methods. So indirect method involves measurement by help of a transducer, which converts the quantity to be measured into an analog or digital. So whatever the thing is, one quantity to be measured which can be converted into either analog or digital, that to be called as indirect method, not to be a direct one. Then move on to the classification of measurement systems. So classification of measurement systems comes under three types. An instrument that to be classified under three types. First is mechanical, second electrical, then electronic. So here we are going to study about electrical instruments. So what the types of electrical instruments means: absolute, indirect and secondary direct one. So secondary direct one have two types: analog instrument and digital instrument. So under analog instruments we have two types: deflection instrument, null deflection. Then comes under deflection instrument, we have three parts: indicating instruments, interpreting instrument and recording instrument. Then move on to functions of such kind of instruments and measurement systems. What are the functions that comes under the measurement systems? First one is indicating function. In this, the system use different kind of methods for supplying information concerning the variable quantity under measurement. So mostly information attained as deflection of pointer of measuring instrument. So for example, deflection pointer of a speedometer. So indicating function in the sense a meter that should have a scale in which a pressure to be applied, then a scale should be move on. So for example, here the speedometer, the deflection pointer of a speedometer. So that to be called as indicating function. The next one, recording function. For every instrument there should be some recording. That recording should be displayed on the displayer. So for what is recording function? It makes a written record, usually on paper. So everything that comes under record on the paper, that to be called as recording function. It records the variations of quantities concerning the time. Example, potentiometer. For example, we can monitor the temperature. So this is the diagram that indicates the recording of graphs in the chart paper. So this instrument to be measured for any potential differences that comes under ECG, EEG. So we can use these type of graphs in ECG and EEG also. These type of instruments for recording. Then we'll move on to controlling function. So what is controlling function? Most important function in the field of industrial control processes. So every system might have some control function for a limit to be called as limit range. So the information used by the instruments or system to control the original measured quantity. For example, thermostat for temperature control. So this thermostat, where we can use this thermostat? For example, it is an AC. For example, we can consider the AC. So we can set a temperature for cooling that particular temperature that cools the room behind the room temperature. So we can set the temperature, that setting point of the temperature to be called as controlling function. Then comes to applications of measurement system. The way the instruments and measurements we can define in three progress. First one, monitoring of process and operation. There are certain applications of measuring instrument that have essentially a monitoring function. They simply indicate the value or condition of parameter under study, and their readings do not serve any control function. So we can simply monitor those functions. We cannot record, we cannot control those operations. Such kind of process to be called as monitoring of operations. For example, ammeter or voltmeter indicates the value of current. We cannot record that kind of readings from ammeter and voltmeter digitally and analogically. We cannot record those things. We can write the measure of current and voltages what it displays. So that to be called as monitoring of process and operation. Then second one, control of process and operations. The variables like temperature, pressure, humidity, etc. may be controlled. The prerequisites is that they can be measured at the desired location in the individual plants. For example, air condition. So here is the feedback loop for simple control system. So initially we can give the input reference, what we need, what we give that to be input reference. Then it gives to the feedback element amplifier, then actuator. Then if the output is not comes under the desired what we expected, then the output is given to the measuring instrument or transducer. So here the transducer, which can convert the output quantity to the what the input reference quantity. So it can convert to the output quantity to the input quantity as such. Then comparator. What comparators does here means it compares the input reference signal and the error signal. Either it is multiplied or addition or subtraction. It can give the desired output signal to the feedback element amplifiers. Here the amplifier, what it can done means it amplifies the signal. So if any small output voltage or input voltage it refers means it can amplify that kind of voltage to some other levels. It amplifies its magnitude. Then it gives the actuator. It gives the actuator simply to be referred as a power. It gives the power to such voltage or current that comes from the amplifier. Then if the desired output, if we got the controlled quantity, that quantity of output, if we got that output means it can the loop must be hold off. So we can get the output, desired output. Then this is same for the servo system, that is systems connected with the measurement of position, velocity and acceleration. So this is the block diagram of simple control system. So input reference, this is the input reference, then this is the comparator, this is the error signal which compares the input reference and the signal from the transducer. Here this is the feedback element amplifier, then this is the actuator. The actuator gives the output. If the output is the desired one, if the output is that what we need means that loop must be end of that position. So we got the desired output. Then move on to experimental engineering analysis. So what is meant by experimental engineering analysis means that prerequisite, that quantity, what and all comes the experiments to analyze. First one, testing the validity of theoretical predictions, then formulation of generalized empirical relationships in case where no proper theoretical backing exists. Then comes to determination of system parameters, variables and performance indices. for development in important spheres of study where there is simple scope of study. Solution of mathematical relationships with help of analogies. So these five categories comes under experimental engineering analysis. Every experiments that should satisfy these five criteria. So this is the experimental analysis. Then comes to standard. So what is meant by a standard? A standard of measurement is a physical representation of a unit of measurements. So standards might have so many varieties, so many types. Here we can consider international standard, primary standard, secondary standard, working standard. So what is international standard? So it defined by international agreement represents certain units of measurement to the closest possible accuracy. So closest possible accuracy related we can measure, we can design that measurements. It is periodically evaluated and checked by absolute measurements and are maintained at the International Bureau of Weights and Measures. Then come to primary standards. These are maintained by national standard laboratories. Primary standards are not available for outside use. Main function is to verify and calibrate of secondary standards. So these are the criteria for primary standards. Then move on to secondary standards. So this is the basic reference standard that used in the industrial measurement lab. So it responsible for maintain and calibration of secondary standard rest entirely with industrial labs. So secondary standard are generally sent to National Standard Lab on a periodical basis for calibration and comparison against a primary standard. Then comes to working standard. It is the principal tool of measuring lab. They are used to check and calibrate general lab instruments for accuracy and performance or to perform comparison measurement in industrial applications. So mainly we used secondary standards. Then working standards. So this is the primarily tool for measuring lab. So thank you.